I have an Aux DC inverter air conditioner, specifically the Mega T3 inverter model, and it's showing an error. I've started the unit and set it to 16 degrees, so let's see what error it shows. As you can see, the indoor unit's display is showing an E7 error code. This means that when E7 appears, the indoor unit is working very well and blowing air effectively, but the outdoor unit has completely stopped. So, the fault is not with the indoor unit, but with the outdoor unit. Let's open the outdoor unit, and then I'll tell you what issue has occurred in the outdoor unit that caused it to stop. Nowadays, most DC inverter air conditioners come with both heating and cooling modes. This makes them much more efficient, ensuring better performance. Now I'll explain the reasons behind the E7 error code. Just like indoor units, outdoor units also have sensors. If any of these sensors faulty, it will trigger a specific error code. Since you're seeing the E7 error, it indicates a fault in the outdoor unit. In this unit, there are about 3 sensors. One sensor's issue has already been covered in a video, which you can check out. The remaining 2 sensors are as follows. The right side sensor in the large connector is the outdoor temperature sensor. If the outdoor temperature sensor faulty or malfunctions, it will cause the unit to display an E7 error. So if this sensor is faulty or not working properly, it will trigger the E7 error code. You need to check the sensor for any issues. It might be cut, short-circuited, or there could be a problem with the wiring or the PCB. The sensor you're referring to is located on the condenser and is responsible for measuring the outdoor temperature and communicating with the PCB. If this sensor is faulty, then its resistance value becomes very important. If you replace it with a sensor of the same resistance value, it greatly improves the performance of the unit. In the upcoming video, I will also provide information about the resistance value. When it gets damaged, what will be its correct position after? The next error code is E3. So, when E3 appears on the display, what does it mean? Now, I'm going back to the outdoor unit and will give you all the information about it. I've opened the unit, and you can see that there is a condenser installed inside the outdoor unit. The condenser's job is to cool down the hot gas. It's cooled through a fan. When the air passes through here, the gas cools down and starts turning into a liquid form. If the condenser gets too hot and overheats, there is a system in place to check whether it's overheating or cooling properly. Let me show you that system so you can determine the current condition of the condenser and the state of the liquid going to the indoor unit. Here, you can see there's a sensor installed called the condenser pipe sensor. As you can see that there are 2 sensors connected to the same connector here. The one on the left side is the condenser pipe sensor. If this sensor becomes faulty for any reason, it could either short circuit, its wire could get cut, the connector could come loose, or there might be an issue with the PCB. In such cases, the outdoor unit will completely stop functioning. That's why you need to replace this sensor. If the fault is in the sensor and it becomes out of order, it can cause problems. So, by replacing this sensor, your unit will be completely fixed. When the E3 error appears, the sensor is usually faulty. However, what's crucial is that the sensor's positive connection must be correctly positioned. If it's connected incorrectly, there's still a chance of errors occurring. I've opened the cover to show the position of the condenser pipe sensor. Now, we can see the entire condenser, including its pipes. As you can see, the sensor is attached to the liquid line. It's installed before the expansion, i.e., before the liquid converts to a gas. This setup allows us to measure the temperature of the gas in its liquid form as it enters. This way, we can ensure proper cooling and evaluate whether we're getting adequate cooling performance. I've prepared the entire setup, and now we will measure the resistance values of these sensors. We have already made a video explaining which sensors are PTC or NTC. By watching that video, you can learn how to test them and determine whether they are PTC or NTC sensors. As you can see, I've set up everything here. Currently, the temperature of the water is 25.8 degrees Celsius. What I will do is immerse both sensors in the water so they can adjust to this temperature. After waiting for 2 minutes for them to acclimate, I will check their resistance values. It's been a sufficient amount of time, about 10 to 11 minutes. Now, I will check the resistance values. As you can see, I've maintained the water temperature as well. First, let's check the value of the outdoor temperature sensor. At 25.5 degrees Celsius, it should give us a certain value. The reading is approximately 4.85 kilo ohms. If it's around 5 kilo ohms, it's within the acceptable range. Next, I'll check the condenser pipe sensor. The current reading for the condenser pipe sensor is 0.490 ohms at 25.5 degrees Celsius. If it's supposed to be 5 kilo ohms at 25 degrees Celsius, it seems we might need a 5 kilo ohm sensor for accurate measurements.